Today we will consider a natural spectrum, that is rainbow formation. To understand the phenomena of rainbow formation, we must first understand few terms which are related for formation of rainbow. The very first term that we will consider is refraction. What is refraction of light? When a ray of light is passing from rarer medium to denser medium or denser medium to rarer medium, then it has a change in its path. When it is falling obliquely, then this phenomena is known as refraction. The phenomena of the change in the path of light as it goes from one transparent medium to other is known as refraction of light. And we have seen that when a ray of light is going from rarer medium to denser medium, the refracted ray moves towards normal. And for this, angle of incidence is greater than angle of refraction. Means this case will be like this. This will be normal and bending of ray of light will be towards normal. This medium will be rarer, this medium will be denser. And ray of light is falling obliquely. It is not falling perpendicular to the interface. When ray of light will go from denser medium to rarer medium, in that case it will bend away from the normal. It means I can consider this is a normal and this is ray of light going. This is denser medium, this is rarer medium. So it will bend away from the normal. This will be angle of incidence. This will be angle of refraction. So when ray of light goes from denser to rarer medium and it is falling obliquely, angle of incidence will be less than angle of refraction. And if it is going from rarer to denser medium, then angle of incidence will be greater than angle of refraction. And if it is falling normally, in that case angle of incidence will be 0, angle of refraction will be 0 and it will go straight. So refraction means when a ray of light is going from one transparent medium to other transparent medium, it changes its path, going rarer to denser medium, bending towards normal, going from denser to rarer medium, moving away from normal. This is for oblique incidence, and falling normally means it will go straight. Next is dispersion of light. In previous video we have done when white light is passing through a prism, then it is splitting itself into its constituent colors or into its component colors. This splitting of white light into its component colors on passing through a refracting medium such as prism is known as dispersion of light. One more phenomena we have to discuss when we will consider rainbow formation, that is the total internal reflection. When we are going to consider total internal reflection, we must consider that ray of light should go from denser medium to rarer medium. This is condition to have total internal reflection. Let us see how does it happen. This is a source or object. From this, various light rays are coming out. So this light ray which is falling normally on this interface, which interface is this? This is separating denser medium and rarer medium. This is denser medium, say water. This is rarer medium, let us consider air. This is object that is kept in denser medium. So the ray of light that is falling normally on the interface, it will go straight. And let's consider this is another ray of light that is falling at point Q. At this point, this is a normal that I have drawn. This is incident ray. And this is a refracted ray. As it will go from denser to rarer medium, it will bend away from normal. And this angle of incidence will be smaller than angle of refraction. Let us consider another ray of light for which this angle of incidence is greater than this angle of incidence. In this case, angle of incidence will be 0. Gradually, we are increasing angle of incidence as we are moving from P to Q to R to S to T. So this angle of incidence at point R is greater than what was angle of incidence at this point Q. Now, with this ray of light falling at point R, this will be refracted ray. Angle of incidence is increasing, angle of refraction is also increasing. So as I will consider increment in angle of incidence, angle of refraction is also increasing, and this ray of light is moving more away from this normal. It means it is moving towards the interface. If I will consider this ray of light from O to S, then this angle of incidence is further greater than this angle, this angle, this angle. This refracted ray will further bend towards the interface, or it will move away from normal, such that this angle becomes 90 degree. And this particular angle of incidence, for which this angle of refraction will become 90 degree, is known as critical angle. This is important point here. When the ray of light is going from denser medium to rarer medium, then that particular angle of incidence at which the angle of refraction will become 90 degree, this particular angle is known as critical angle. What happens if we will increase further angle of incidence such that this angle of incidence is greater than this critical angle? Then this angle will further increase. This ray will move more away from normal. So result will be this ray will enter into the same medium. This particular phenomena, when the ray of light is trying to go from denser medium to rarer medium with angle of incidence greater than critical angle, and it comes back into the same medium, this is known as total internal reflection. For this phenomena to happen, conditions are ray of light must go from denser to rarer medium, and second condition is angle of incidence must be greater than critical angle. When these two conditions are satisfied, only then ray of light will come back in the same medium, and this phenomena will be known as total internal reflection. So what is total internal reflection? The phenomena in which ray of light is going from a denser to rarer medium and is sent back to the same medium, provided angle of incidence is greater than critical angle, and then we will consider the entrance of ray of light again or coming back of ray of light again in the same medium. These three phenomena, refraction, dispersion and total internal reflection, they are going to play a vital role when we are going to observe rainbow. When do you see rainbow? Rainbow you can see during rainfall, after rainfall, or rainbow formation can be due to water fountain. It can be due to waterfall also. During rainfall or after rainfall, what happens? Water drops or raindrops are suspended in air. And when sunlight falls on these water drops, then these different phenomena at different phases of that raindrop or water drop are going to take place. Let us consider one by one. This picture is showing formation of rainbow, and this represents a water drop. When sunlight is falling on this, then this water drop will act like a prism. When it will fall at this point, then refraction will occur because ray of light will come from rarer medium to denser medium. So at this point a refraction will be there, bending of ray of light will be there. Also, as this drop is acting like a prism, dispersion of light will also take place at this part. So here we have white light, refraction is going to take place, and due to refraction we are going to have a band of 7 colors here. When these different colors, now we are going to consider red and violet only, extreme colors. When these colors will fall on this face of drop, this part of drop, now this color will try to go from denser medium to rarer medium, because inside water is filled, outside air is there, and if angle of incidence at this point is greater than critical angle, this light will not go outside but it will suffer total internal reflection like this. So till here, which phenomena we have considered? At this point refraction is taking place, dispersion of light is taking place, at this point total internal reflection is taking place, and at this point ray of light is trying to go from denser to rarer medium, but here angle of incidence is not greater than critical angle, so it will suffer refraction and it will come out in air. So this is incident ray of light, at this point suffering refraction and dispersion. At this point red light is suffering total internal reflection, violet is suffering total internal reflection, but at this point total internal reflection will not be there, it is going to suffer a refraction, and then these rays, when they reach to our eyes, then we can see formation of rainbow. Let us try to understand once again. When sunlight falls on raindrop or water drop suspended in air, then this drop acts like a prism, and light suffers refraction and dispersion also. Refraction, splitting into 7 colors, will be dispersion. Due to dispersion, it is splitting into its component colors. Different colors, when they are falling on opposite side of drop, they suffer total internal reflection. Why? Because they try to go from denser to rarer medium, and at these points angle of incidence is going to be greater than critical angle. These reflected light, when reaching on the lower surface of drop, they suffer refraction once again, and we get formation of rainbow. This type of rainbow formation you can have due to presence of water drops near waterfall, and presence of water drops in air when you are going to have water fountain. So in absence of rain also you can have formation of rainbow, that is due to presence of water drops in air due to waterfall or due to water fountain. So which phenomena are responsible for rainbow formation and how? This I have explained. Refraction, twice refraction here and once total internal reflection, means this ray of light refraction, total internal reflection, refraction and dispersion. So we have considered these phenomena responsible for formation of rainbow.